Okay, so this is our second video of the modes of heat flow. Okay, so the learning goal, the first one, conduction, we've done. Okay, so right now we're on the convection. We're on this one. Okay, and so what do we mean by convection? Let me have a very brief review of like a recall of the analogy right here. So remember the task is like to get students to pass the energy from one end to the other, like from a stack of books from one end to the other. Okay, so last time we've demonstrated how conduction works. It works like you need to transfer the book one by one through the queue without any movements of the students in the line. Okay, but for convection it's a little bit tricky. Okay, so for convection, we remember you need to get the first one who get the energy to move all the way towards the end of the queue. But while he's doing so, he has created a void right here. So this is a void create. Okay, and so that means to keep the formation of the queue, the rest of the line must move forward to fill the void. Well, it creates a space. Oh, okay. So it creates a space for the one carrying the energy to fill in. Okay, so that's how it works. So in the end, the energy actually goes from one end to the other. Okay, so that's convection. Remember, convection, unlike conduction, you do involve the bulk movement. So everyone in the line, they need to move. Okay. Okay, so that's pretty much. And also, I'm going to give you video to watch. So last time I forgot to show you the link. The link's right here. So if you have a handout, you just could click in and watch. Okay, so I just tried to show you the part with convection. Okay, so you see there's a match. Okay, we know when there's a match and the flame right here, the fire is right here is really hot. And you could see the smoke. Okay, so smoke, you visualize the flow of the air. So when smoke rises, that means the air also rises. So the problem is why the air they will rise up. It's because when those air molecules they got heated up, okay, and understand if you got heated up, those air molecules they move faster. That will create a greater space between the air molecules. So for that region, the density of the air actually is less than the rest of the region. Okay, so you have an expanded air region there. So it creates kind of void. So listen, so there's a void right there, just like what we did in our previous analogy. Okay, so and what happened is after that,
Probably not the best
you will
idea to
see
hold your hand above an open flame like this.
you
And
keep
that's
flowing
because a
up.
lot of the heat
Okay,
in the flame
so
is going to rise because of the process of convection. You see, what's happening is
that's what we mean by the convection. You actually could see it if there's smoke. Okay, so let me use another picture in the handout to demonstrate the idea. Okay, so you see when we have heater at the lower corner. Oh, sorry. At the lower corner of the house. So this is a heater. Okay, around the heater, the air molecules warmed by the heater. Once it's warmed, that means the air molecules, they tend to move apart from each other. They will create a greater space. Okay, so that means the density drops right here. Okay, so when you compare the air molecule elsewhere, okay, obviously they will have less kinetic energy, so they can stay close with each other. Okay, so the problem is when you have such a region of air molecules, they are not that close together, and so for this part of the air, the density decreases, and also the air pressure from the other region will push it up. So this hot air will rise up from the lower place to the higher place. Okay, so hot air is less dense and falls upwards. So right now the hot air is right here. So these are hot air. They are still hot. Okay. Okay. So you see the hot air is right here. Okay. But since those hot air, they tend to rise up, so it leaves a void right here. So there's a void right here. Okay. So that means there's some space to be filled in. Okay. So what kind of air molecule will go to fill in? Of course, you are going to get the closed region to fill in. All right. And those air molecules just next to that region, the void region, they attend to the first bunch of air molecules to go into the void. Okay, so this is this region. Okay, so and this is a colder area, colder air. Sorry, and the colder air, they tend to move in to fill the void, Okay, and so on. So and then you need some other air to descend to fill the void left behind by the cold air. So you have more cold air right here. Okay, so it's cold air right here. Okay, and in the end, there's another void created right here. So remember, there's hot air rises here. So and you will fill in that place. Okay, of course, in doing so, because it has traveled a long way from the heater, so this air will tend to cool down. Oh, sorry. Oh, sorry, what happens? So I just want to undo it. Oh, it's such a... Okay, it just cooled down a little bit. Okay, so that's why, that's the whole thing. Of course, it might still hotter than the previous cold air there, but it just colder than the hot air it just formed, which is just from the heater. Okay, so that's create a cycle. So that's what we call create convection current. It's like a cycle. So the hot air rises up, and then the cold air to fill the void, and they just create a cycle of the convection. Okay, that's why we shall install our heater, okay, at the lower place of the room. Well, you should install your air conditioning for the cold air at a higher place. Okay, so that's why we should understand the mechanism right here. Okay, in convection, thermal energy moves between 2 points because of the bulk movements of matter. This can only take place in a liquid or gas. What's the collective name for a liquid or gas? Fluid. So I know in your daily life, fluid normally means liquid, but in physics it means gas as well. So why we need fluids? Because you need that kind of bulk movements. In solid, the particle, they can't be displaced. the part of the fluid is heated, it tends to expand. Okay, when you heat it tends to expand, and thus its density is decreased. Okay, the colder fluids sink and the hotter rises. Okay, central heating causes a room to warm up because of convection current. So remember, convection current is a cycle like this. Okay, points to note: convection current can only take place in fluid. Well, we know conduction can take place in cannot take place in solid. So conduction can, but convection cannot. Okay, so there are plenty of examples. Pilot gliders are naturally occurring convection currents in order to stay above the ground. Okay, sea breezes are often due to convection. Okay, okay, I could give you a very brief diagram of this. So, for example, if you have sea here, so this is land. Okay, so when during the day, if you have sun right here, so we know that's heat supplied right here. Okay, so in the land, the temperature rises much quickly. So this part is much hotter, and this part is much colder. Okay, so that means in the hotter parts, the air molecules, they tend to rises, right? So it's rises, so it's hot air. Okay, and they must form a convection hot current. Okay, after they come into the sea. Okay, so this is the cold air. Sorry, this is a pain. So this is cold air. Okay, again, hot air rises, cold air sinks, and then they fill the void left behind by the hot air. So this becomes the breeze. So that's why during the daytime the breeze is always from the sea, but it reverses during the evening. Okay. Right, lighting a fire in a chimney will mean that a breeze flows in the room towards the fire. Okay. Okay, so that would be a question to show you this experiment. All right, so let's have a quick look of the work example right here. Which statement refers to convection? It does not involve energy transfer. No, it does involve. It is the transfer of heat energy without movement. Without movement, no. That means conduction then. It only occurs in liquid or gases. Yes. It only occurs in solid. Sorry, no. Okay, so it's very basic. Where should be a heater placed in the room? Which diagram shows the movement of air? Okay, have a quick look of this one. Okay, I will give you some time to determine this. I'm not going to pause the video, but you might take 30 seconds to have a quick look. Okay, and C and D, obviously they are not the answer because it shouldn't be lateral movements. It must be upward and downward movements, and it must be from this is hot area and this is cold area right here. So hot area, hot air just rises. Okay. Okay, a beaker contains water at room temperature. So there are, how could a convection current be set up in water? Okay, so there are a few ways to do it. The first one is to cool the water at X, you can place some X. So place some ice around X, or place some ice around Y. And also you can stir the water at X or stir the water at Y. Okay, which one will you get it? So you might need to think about this a bit longer. So let me give you 2 minutes. Okay, I pause the video. Okay, so let's consider if you try to cool the water at Y, then what you're going to do. So if Y is being cooled, so that means this area becomes colder. Okay, so if this area become colder, what happens? Okay, because we know cold water can't rise. Okay, so you can't have cold water rise, and it has nowhere to go because it's already cold. Okay, so it's not going to work. It's not going to work. Okay, so how about if I get X colder? So relatively speaking, then Y is hotter, right? So we know, okay, so if this region is colder, so that means the colder water will sink. Okay, will sink. All right, and you need to have warmer water to fill in, and this part is relatively hotter. Also, you create the convection current. Okay, so obviously this one is the answer. How about stir the water? Stir the water can't create the convection current due to a temperature difference. It's a mechanical convection. It's not a thermal convection, so there are differences. Okay, the diagram shows a cooling unit in a refrigerator. Okay, so in this case, the cooling units on the top of the refrigerator. All right, so what's the cooling? Why? So you need to give a reason. Place it at the top. Okay, cold air force and the warm air displays upwards. Is that good? And okay, how about cold air's back conductor? Oh no, it's not about conduction at all. It's not about conduction. Although air is a poor conductor as we know, but it's not relevant in this case. Cold air stops at the top, so prevents convection. No, cold air won't stop at the top. It might stop at the bottom, but not the top. Okay, so A is the answer. Okay, for this one, a heating element is placed in a narrow seal tube of liquid. What would be the best place to position the heating element? So I need to place the heating element in order to obtain the best circulation of the liquid through the tube. The best circulation of liquid. That means convection. That means best convection current. Okay, so this one is pretty interesting. So I'll give you 2 minutes to think about this. Okay, let me pause the video again. Okay, so I guess many of you with, okay, so obviously A and B, they won't be the answer, right? Because if you want to heat up something, you always place the source of heat at the bottom of the system, not on the top, because you need that hot air have some place to go. Okay, and I guess most of you, or not most, many of you have chosen D because you want to have D being heated up. So if you put your heating element at D, what happens? So if you put your heating element at D, so this part becomes hotter. Okay, and the rest, and this part becomes cooler. Okay, so obviously the hot air tends to rises, so you need to go this way, get the hot air, okay, rise. So hot liquid rises up here. Okay, so but the problem is, in the end, okay, they will meet here, but how about the void left behind in the bottom? So there's no current, okay? There's no sustainable current, I should say. Okay, so it looks like more one-off. You can't when the hot liquid sent from D meet at B, and that's it, because they tend to squeeze each other. Okay, so it won't work. Okay, so we need to think about other way. Okay, so the only possible answer should be C. So this part become hotter. Okay, by doing so, when this part become hotter, the hot liquid, it rises right here, and you create a void here. Okay, and you go all the way. So if you visit the colder region, and it goes back, you hit again, and the cycle goes on forever. All right, so that's why I think the answer should be C in this case. Okay, so the diagram shows a block of ice placed in the warm room, at which point the temperature the lowest. Okay, it's a warm room, so that means the place around the ice should be colder than the rest of it. Okay, so let me eliminate A because it's further away from ice. Okay, which part should be the lowest? Okay, think about this. It might take like 30 seconds to think about this, your answer. Okay. Okay, so the answer is dog. Why? Because this part is obviously colder, and the rest of them are warmer. Warmer here, and warmer here, right? Agree? Okay, because the rest of part is the room, and the room is warm. And okay, so if this is colder, so that means the air molecules around the ice will be cooled first. Okay, and they tend to the cold air. So let's say the cold air right here. So it's cold air right here. They tend to sink. So they move downwards. Okay, and there are some cold air right here as well, but that they don't tend to move upwards. So that's why they are not that eager to visit B. And the cold air right here, they are not so eager to visit C as well. But the cold air underneath the ice, they are eager to visit D because cold air sinks. Okay, so the answer is D. Okay, so this one is the one I mentioned before in our brief notes. So there are 3 examples. The last one, lighting a fire in a chimney, will mean that a breeze flows in the room towards the fire. What does it mean? So normally people got puzzled by this statement. So I will show you in this example. Okay, so there are 2 chimneys. Okay, a teacher demonstrates convection current. So convection current again, using a box, 2 chimney, and lighted candle. Okay, why do we need a light candle right here? In which there are and holds a smoking taper at the point P. So here there's a smoking taper. Okay, so normally we understand the smoke goes upwards, right? So in which direction does the convection current cause the smoke to move? So that means how the smoke move? from that smoking taper. Does it rises like what we normally see, or it goes sideways, or even downwards, which would be really interesting? Remember, there's a candle right here. Okay, so my hint is when there's a candle right here, so that would be hotter region. And okay, so how about the rest of them? The further away from that candle, you mean, okay, so this side should be colder. Okay, so then what happens? Okay, so I give you 2 minutes to think about this. Okay, I pause the video. Okay, so let's have a look. Okay, so which direction will the smoke goes? Normally it will rise, okay? But in this case, definitely not. Why? Okay, let's think about the convection current from the hottest spot, which is the candle. So that means the hot air would just rises here, okay? They just rise up, hot air from that chimney. Okay, then you would think, okay, so when hot air goes up, so that will create kind of void right here, okay, waiting to be filled in. Okay, so we have plenty cold air right here, so they're going to fill in. So can you see that's kind of convection current? So hot air rises and cold air comes in. Okay, cold air comes in. So how about the smoke right here? Because the air around this region is also colder, right? So that means if you have a colder air comes to fill in the void left behind here, so there's another void created. So that means you need that cold air from above comes in to fill that void. Okay, in doing so, that those cold air they will drag the smoke with it. Okay, so that means the smoke will go from that chimney towards goes downward through the chimney. Okay, so it's really interesting. So you will see some hot smoke. So this is hot smoke from the candle. So this is the hot smoke, and this is rather colder smoke from that taper. Okay, so that's how can we create smoke flows downward rather than upwards in one chimney. Okay, right. So the answer is D, of course. Oh, good. Okay, so we see that this is example 13. Heater used to heat a tank of cold water. Okay, tank of cold water. What's the main purpose of by which heat moves through the water? Okay, main process by which heat moves through the water. So there are a couple of ways: conduction, convection, evaporation, radiation. Through the water, it must be convection. Okay, so conduction, yes, water can conduct heat, but it's not as effective as convection. Okay. Okay, example 14, you might take some time to think about this. In which test tube will the ice take the longest time to melt? Okay, take the longest time to melt. Most difficult to melt, that means. Okay. Okay, take your time to think about this. Okay, so if you make up your mind, you could take more time and pause the video anyway. All right. So let's see the most unlikely answer. So what? So of course this one won't be the answer, right? It will take the shortest time because the ice is right here. You just hit it right on the button, and you could see that would be a convection current right on the ice. Okay, because there's heat just right below it. Okay, how about D? D, we know this one here is colder and this part is hotter. And so the hotter current goes up and the colder current goes down. So you create a convection current. So you transfer the heat effectively. And so this one will take shorter time. So this one won't be the answer. Okay. So when I say it's wrong, it doesn't mean you can't melt the ice. It just means it will take shorter time to melt it because our question is about the longest. It's most difficult, most ineffective in terms of melting the ice. Okay, so how about the other two? Okay, so the gut feeling will guide you to think about B because the fire and the ice are further away, and also that's one fact. When the heat this way, so this part become hotter and the ice right here colder. Okay, so you have hotter water above the colder water, so no convection currents can be created. Okay, so in this case, no convection currents uh, currents can be created. So that means it's most ineffective way to melt the ice. Okay, so right here, you try to, for A at least you try to heat the ice directly underneath. So there's some chance you can still melt the ice, but not as effective as the other two ways. But B is definitely the most ineffective way to melt the ice. So B would be the answer. Okay. So there are lots of questions right here. So this one is just similar to the one we did before. So you have thermometer above, thermometer below, and which thermometer reading changes. Okay, so because ice cube right here, which is colder, so anything anywhere else is warmer. And the cold air around the ice cube, they are not going upward, they are going downward only. Okay, so that means the Y, you will see the temperature drops. The temperature drops in this way. Okay, and so the answer is Y. And reason, cold air force from the ice cube, warm air force, no, it must be cold air force. Okay, let's see. A beaker of water heated at the base, so it's quite similar question. Why does the water at the base rises? Okay, because it expands, become less dense. So, okay, expands of course become less dense. Okay, so that's the answer for 16. Okay, so the last mode of heat transfer is radiation. I would leave that for my last video for this handout. Okay. Okay, see you next time.